This might be our future, by the way. Camera started. Okay. Let's start this. This is quantum computer. And this code is running right now on this quantum processor. And in 12 seconds, you're going to see something impossible. See that those results just came back from IBM's quantum processor. And what you're looking at is the difference between what computers can do today and what becomes possible in next 5 years. And in that 5-year gap, that's where we solve humanity's biggest problems that we have been stuck on decades: climate change, diseases, energy. But here's the problem: most people don't understand quantum computers. And if you don't understand this, how you're gonna build the future? Because the future will be built upon this. So let me show you. Right now in 2025, climate scientists run supercomputers 24 into 7 trying to model atmosphere, but they can't account for every variable. Ocean currents, ice feedback loops, carbon cycle, it's just too complex. Drug development, it takes 5 to 10 years just to produce one drug. Why? Because we test thousands of molecules to find the perfect one that works. And AI has a limit. The bottleneck isn't the money and it's not the time. It's the fundamental way of how our computer works. Every computer you have ever used works with bits, 0 and 1s. It's like on and off. That's quite powerful, I mean. But it has a ceiling, and quantum computers break that ceiling. They don't use bits, they use qubits, which means qubits can be 0, 1 and both at the same time. That's their super advantage, and that changes everything. And I'm going to prove it right now. Python code that builds quantum circuits. Watch what I'm doing here. I'm creating two bits. I'm putting them in superposition with this gate. Then I'm entangling them, which means whatever happens to one instantly affects the other one. And now I'm sending this to IBM's quantum computer for our actual process in real time. This is running on 127 qubit hardware, not a simulation, but an actual quantum processor. There, see this pattern: 00110011. When the first qubit is 0, the second qubit is also 0. When the first qubit is 1, the second one is also 1. That's called entanglement, and Einstein called it a spooky action at a distance. And this is right here is the foundation of everything. Drug discovery, climate modeling, AI acceleration, it all starts with this. Now here's where it gets crazy. What can quantum computers solve actually? Three things, and they are massive. Quantum computers simulate molecules, atom by atom, electron by electron. That means better batteries, carbon capture catalysts, solar cells that are 3% efficient than the current ones. Not through trial and errors, but through quantum simulation. The energy crisis will be solvable by 2035 if everything goes well. Pillar 2. Instant drug discovery. Right now, drug development takes around 5 to 10 years and it costs around billions of dollars. Quantum computer can simulate how a molecule interacts with a target disease instantly. Imagine a new virus came in and we just got its vaccine in just 1 week. That's how we can save millions of lives and a lot of money. But if we had to invent a drug by a traditional way, it is gonna take off years of work. In that time, I think the population of Earth will be gone. So that's why we need quantum processor. Pillar 3. Science fiction become real. Room temperature superconductors, lightweight superalloys, all that's 1000% more powerful than the current one. It means flying vehicles, flying warships, and one thing which is gonna be possible: space exploration, which I'm most excited about. Why? Because all of this requires optimization problem that quantum computers can solve naturally. This isn't three separate futures, but one. Here's the timeline. Right now in 2025, we have quantum advantage for a specific problem. We can beat classical computers at certain tasks, but we can't solve real life problems yet. Think of like this: we are at the stage AI was in 2022, before ChatGPT and before AI era exploded. And by 2027, early application might work and we'll have some climate models, some drug simulations. And in 2029, the watershed moment, IBM is building the world's first large-scale fault-tolerant quantum computer. By 2030, we enter an era where we are taking the advantage of quantum computers on real-life problems. And that's not 100 years away, that's not 50 years away, that's probably 5 to 10 years away at the max. I might be wrong at this statement, but if everything goes well, how I'm thinking about it and how I'm seeing the world, how much of the effort top people are putting in this thing, I think this will be the timeline. So the question isn't will the quantum computers can change the world? The question is, will you be the one